Hello everyone, this is Yemi. In this video, I will be discussing enthalpy change. Enthalpy change, the symbol is delta H. Enthalpy change is equals to its content of the product minus its content of the reactant. Enthalpy change equals its content of the product minus its content of the reactant. So HP represents its content of the product and HR represents its content of the reactant. And its content of an element is equals to 0. The its content of an element is equals to 0. The its content of oxygen gas is 0. The its content of hydrogen gas is 0. So we have condition under enthalpy change. The first condition, when the enthalpy change is positive. So for the enthalpy change to be positive, that means that its content of the product is greater than its content of the reactants, and the reaction is called an endothermic reaction. So an endothermic reaction, the enthalpy change is positive. That denotes that the its content of the product is greater than the its content of the reactant. The second condition, when the enthalpy change is negative. So for the enthalpy change to be negative, that implies that its content of the reactant is greater than its content of the product, and that type of reaction is called exothermic reaction. So exothermic reaction, the enthalpy change is negative. UTM question, we are given a reaction 2CO plus O2 to give 2CO2. The enthalpy change of CO is carbon monoxide. The enthalpy change is minus 110.4 kJ per mole, and the enthalpy change of CO2 is carbon dioxide. That's minus 393 kJ per mole. Calculate the enthalpy change. So CO and O2, that's the reactant. CO2 is the product. So enthalpy change equals its content of the product minus its content of the reactant. So the enthalpy change will be equals to 2 times its content of CO2, that's the mole ratio of CO2. The mole ratio of CO2 is 2, that's 2 times its content of CO2 minus the mole ratio of CO, that's 2. That's minus 2 times its content of CO plus the mole ratio of oxygen gas, that's 1. So 1 times its content of O2. And the its content of O2, that's 0 because it's an element. So the enthalpy change will be equals to 2 times its content of CO2, that's minus 393. So 2 times minus 393 minus 2 times its content of CO, that's minus 110.4. So the enthalpy change will be equals to minus 2 times 393, that's 786, minus 786, and minus times minus is plus. 2 times 110.4, that's 220.8. So the enthalpy change equals minus 565.2 kJ per mole. So that's the enthalpy change. So the next aspect is gas-free energy, and the symbol is change in G. So gas-free energy is equals to enthalpy change minus T change in entropy. Enthalpy change minus T change in entropy. So change in J represents the gas-free energy. Change in H, that's the enthalpy change. T change in X, that's temperature dot entropy change. So we have condition under gas free energy. So the first condition is when the gas free energy is negative. So when the gas free energy is negative or less than 0, that implies that T change in entropy is greater than enthalpy change, and that type of reaction is called a spontaneous reaction. So that's the first condition. So the second condition, when the gas free energy is positive. So when the gas free energy is positive or greater than 0, that implies that the enthalpy change is greater than T change in entropy, and that type of reaction is called a non-spontaneous reaction. And the third condition is when the gas free energy is equal to 0, that implies that the enthalpy change is equal to T change in entropy, and the reaction is at equilibrium. So when the gas free energy equals to 0, that means that the reaction is at equilibrium, and when the gas free energy is positive, that's a non-spontaneous reaction, and when the gas free energy is negative, that's a spontaneous reaction. So UTM question: a chemical reaction with entropy change of 20 joule per Kelvin and free energy change positive 55,000 joule occurred at minus 20 degrees Celsius. Calculate the enthalpy change. So the entropy change is 20 joule per Kelvin. The gas free energy, the free energy change, that's 55,000 joule, and temperature is minus 20 degrees Celsius. So we convert to Kelvin, that's minus 23 plus 273. So to convert Celsius to Kelvin, we add 273. That's minus 20 plus 273, that's 250. So that's 250 Kelvin. So gas free energy equals enthalpy change minus T change in entropy. So enthalpy change equals gas free energy plus T change in entropy. So enthalpy change equals 55,000, that's the gas free energy, plus the temperature is 250, and the entropy change is 20. So the enthalpy change will be equals to 55,000 plus 250 times 20 is 5,000. So 55,000 plus 5,000, that's 60,000 joule per mole. That's the enthalpy change. Thank you for watching. My name is Adekambi Yemi.